Thanks a lot for the great introduction, because it's actually really great to be here today at PyData London on this maybe surprisingly sunny day. And yeah, we're really excited to see this room full of people to together with us learn about MLOps and specifically whether you are ready for it. So before we start, we would like to introduce ourselves. So I'm Jeroen Overschie. I'm a machine learning engineer at PyData. PyData provides consulting for data and AI. And what we do as machine learning engineers is we help companies take machine learning applications into production. And I'm here together on stage with Jetze.
Yeah. So welcome everyone. Jeroen has implemented a lot of MLOps tooling across different companies, and we both developed MLOps trainings. I created an MLOps maturity scan where we assess how mature companies or teams are with regards to MLOps and what would be the next steps for them in order to become more mature. And in other words, we both spend a lot of time thinking about MLOps. What does it mean? And we see in industry that there's quite a few misconceptions about MLOps. And we want to give back to the community, so that's why we're here. Yeah, without further ado, Jeroen, let's dive right in.
Thanks, Jetze. So to start, the title of our talk is, are you ready for MLOps? So first we like to together define a bit, so what does it even mean to be ready? So I want you all to look at the house on the right side. So you can see at the top it is a beautiful house, but for some reason it collapsed. And the most probable reason that it collapsed is because its foundation was not very strong and well built. So in a way, the timing was not correct to build this really nice house on top of this not so very good foundation. So what we want to investigate in being ready for MLOps is first understanding why do you even need MLOps? Also, what is MLOps? But especially when is the timing right for MLOps? And that we want to investigate. And to do that, first we want to see, okay, so this entire MLOps thing, you might have heard about it, but what does it promise us? What is this great thing called MLOps? So why would you want to do MLOps? So as consultants, we go to companies, we see them struggle with the same type of challenges. So one struggle that we can observe is that companies, sometimes they end up in very long development cycles to launch their machine learning applications. This is to both create models, to update models, or add new features to models. And that can sometimes take very, very long. What we also see is that models lack a proper feedback mechanism. So that allows us to get insight in what kind of value is the model bringing and how is the model performing. And also what we see, there might even be few models that even make it into production. And if you remember in yesterday's keynote, Rebecca also explained actually only very, very few do indeed make it in production. So there's this news article from Gartner that explains only half of AI models actually make it into production. And we even found an article that depicts an even worse prediction. Only 87% of data science projects, they never make it into production. So that is not a very pretty forecast. And we were actually wondering, why is this? So why is this struggle so big in actually getting all these data science projects into production? Because we thought, okay, in 2024, we know how to do machine learning. We have all the tech that supports us. We have all these great libraries and tools, of which the PyData conference has a lot of tools surrounding this ecosystem. So you have scikit-learn, TensorFlow, you have all sort of tools that can help us, but also the skills are there. So on the left-hand side, you can see there was an article which says more than 100,000 people started the deep learning course offered by fast.ai. So that really shows, okay, there is definite interest and people want to upskill in this domain. And also there is plenty of studies around, plenty of material. Like on the right side, University of Amsterdam offers courses on data science. So it has been some time since data science was promoted as the hottest job of 21st century. Like we have spent some time now. And also there's meetups like PyData that share the knowledge. Like we have quite extensive knowledge now on how do we build machine learning models. But that is still focused on the development of machine learning. So we can build all these models, but that still doesn't mean that at companies we can actually see them in production. And that is why we now are dealing with another team or another type of people, so which is on the operations side. So once we develop a model, we can often see that at companies there is another team which is responsible for actually putting it in production or also maintaining it in production. And between these two parties, there can be a bit of tension here. So the tension, so why is there tension between these two parties? So development operations, they can speak like entirely different languages, almost literally, right? So on the left-hand side, you might develop in Python. On the right-hand side, there's operations teams, they deploy it in Java. You have different roles. You have a data scientist on the left side. On the right side, maybe a platform engineer, and you care more about reliability. And on the left-hand side, you want to be more free. You want to be able to experiment. So this creates friction. And also at companies, you often see, okay, there's a handover. And in between that handover, a lot of context get lost, lost in translation, as you can say. So this is problematic, the gap between development and operations. But now our talk would not include the word MLOps if MLOps would not come to the rescue. So then we have this great magic of MLOps, which then comes to help us because this is machine learning operations connecting the two worlds together. So where does this come from? So actually I want to plot MLOps. Where is it currently at? What is the state of MLOps currently? Where is it on the hype cycle? So the hype cycle, it represents a graph where we can plot technologies in terms of maturity, adoption, social application. So where is it currently at? So you can say MLOps, it is actually just out of the peak of inflated expectations and we're just coming down. But we actually state, okay, no, we're actually going up. We're actually out of the trough of disillusionment and we are going up in the plateau of productivity. So we are getting more mature now in terms of MLOps. So what does that look like? So what is MLOps about? So we can see a lot of different aspects which we can categorize as doing MLOps. So for example, in the middle we have this machine learning model and we have all stuff around it. We want to configure it and we want to properly monitor it. You want to schedule a pipeline. You want to orchestrate it, do feature engineering, in the end serve it as an API. And all these features, we can concretely map them to some MLOps specific components. So which are they? There's, for example, experiment tracking, data set versioning, then we have a model registry, and then we version models in that registry. Then we can deploy our application as a pipeline and we can launch the pipeline also from CI/CD. And then we want to monitor the entire thing. So to give you a better idea of what each of these components is about, let's briefly visit them in detail. So let's look at experiment tracking. Here on the left-hand side, you can see a screenshot of a very popular open source tool to do experiment tracking, which is called MLflow. And the main purpose is to record everything that you're doing in terms of training models and capturing what is the performance of the model. So there you can easily see, okay, what is the metric that I currently get when I train my model on which data. Then dataset versioning. So here we can see yet another tool, HML, which then records, okay, exactly with which data did you run your machine learning pipeline. So then it becomes nice and traceable and reproducible. So you don't forget, okay, which data exactly yielded the best performance. So then a model registry. So here we can see Vertex AI, where we are recording each of the models that we train, so we nicely store them as an artifact, which in the backend gets stored in a blob storage. And then we also want to be able to version those models. So here again, Vertex AI, and you can see, okay, we can also make distinctions between a version of a model that we put in a staging environment or a development environment or production environment. So we can use these tags also to point to different environments. Then we also can have machine learning pipelines. So in this case, you can see SageMaker, which is another tool to do MLOps. And we can see that this creates transparency. So you can see exactly, okay, where does the data currently flow? In this case, the pipeline is nice and green, but you can also see, okay, this is exactly the place where my pipeline failed, and it will be red. Then we have CI/CD. So in this case, GitHub Actions, which is important also to automate everything. So from your testing, or maybe to launch a pipeline with few data just to validate the integrity and the functionality of your pipeline. And lastly, monitoring. So here we can see an Azure product Log Analytics workspace where we can verify, okay, with what latency is our API performing. So we want to keep track of all these things, and all the screenshots that I was showing, they showed different services to solve these MLOps questions with. And what we can actually see is, since some time, most of the huge cloud providers, they also provide MLOps solutions for us. So by this time, MLOps has become more mature, and we can see, okay, what do the clouds offer off the shelf for us. So then, if we go back to the slide where we observe different difficulties at companies, then we now understand, okay, why do we need MLOps and what is MLOps? Maybe we can see if we can tackle these previously mentioned points. So long feedback, long development cycles, lacking feedback, and few models in production. So the MLOps promises that we just formulated by looking better at MLOps are the following. So we can see that we can speed up development with automation and collaboration. We focus on rapid feedback and iterative development, and also we enable autonomy for end-to-end product teams. And this sounds really great. So if you hear this, then probably everyone wants MLOps. But we still wonder, okay, where does this come from? So these promises, they didn't come out of nowhere, and MLOps also didn't come out of nowhere. So we want to go back to this slide where we see the tension between the development and the operations world. And so we wonder, okay, how did MLOps come into play? and especially how did we solve the tension between development and operations, and then actually we arrive at a concept that we can even make of these two words, development operations, DevOps.
Yes, exactly. So, as Jeroen mentioned, part of what MLOps is trying to achieve is bring development and operations closer together. And there is already this thing called DevOps. And DevOps has been around since roughly 2007, when it got more popular. And the goal was already at DevOps to bring development and operations together. And for some of you, this iterative cycle might look very familiar. It's basically an idea of how you can continuously deploy, continuously deliver on coding projects. And this concept has been around for a while. The idea of bringing development and operations together is also not new. And people use that as an inspiration for MLOps. But what is sort of being forgotten here is that it's not just about this cycle and getting things faster to production or simply creating a lot of nice DevOps tools for this. This idea was actually founded upon 5 key principles. The first one being collaboration. You want to have the team of developers and people from operations come together, collaborate in end-to-end product teams. And what you want to do is you want to automate as much of this process as possible to ensure that you can quickly deploy and continuously deliver. Good candidate for automation would be, for example, deployment or your CI/CD pipelines during deployment. And what you're trying to achieve is continuously improvements. So the way that you can improve a system is, first of all, you have to collect feedback from that system. And I think this is also something that we need to always keep in mind, especially also working in machine learning systems. And what do we want to continuously improve with regards to? We want to improve the experience for the end user. So in the end, we want to have that feedback cycle to know what the customer needs, if the system is still operating properly, and how we could improve that system. And while this is a continuous loop, we also want to keep in mind the 5th principle, create with the end in mind. We want to create chunk size blocks of improvements as small as possible so that we can incrementally improve. By creating these blocks as small as possible, we can also more rapidly deploy them, more rigorously test them, and thereby ensuring that we have a smaller time to production. Then people often motivate that machine learning is much more complex than DevOps. DevOps doesn't cut it, so we just want to move straight to MLOps. And yes, that's true. In the scenario where you need MLOps, for example, one where you collect a lot of data, you train models based on that data, there's a lot more complexity in your system. And yes, you do need MLOps-specific tooling for that. But it doesn't mean that you cannot learn from DevOps, which in our opinion was mainly focused on building tooling for coding. Because if we look at a typical machine learning pipeline, I hope this is readable, we start off with the model building phase, we do experimentation, from there we make a candidate model that we want to productionize, we test the system, deploy it, and then start to monitor the system by creating observability and creating this feedback loop in order to see how we can improve the next generation of models. And what we can see here is that across the whole pipeline, across the whole machine learning pipeline, a lot of parts require code. And in those components, we can therefore also learn from DevOps. But we can also see that the model and the data part also come across at all of these different stages. and therefore they both need to work together. But if we simply look at the tooling that might be needed for such a project, as a start, we might want to start with rigorous testing, linting, CI/CD pipelines, version control, configuration management, containerization, all things where we can learn from DevOps. And if we make sure that we get this right, then that would lay a great foundation for the tooling that we can build on top of that, namely the tooling that Jeroen also motivated before, that we require for machine learning projects, scheduling, orchestration, monitoring, drift for model drift or data drift, the machine learning pipelines, experiment tracking, etc. So all of these MLOps technologies build upon ideas from and technologies from DevOps. So if you do not make sure that you are working according to DevOps best practices, in our opinion, you don't have the right foundation for your machine learning MLOps technologies. So if you improve your MLOps tooling and processes, then on top of that, you can improve your MLOps practices. So we need DevOps as a fundament for our MLOps tooling, but what's the MLOps twist here? The twist is that what I just mentioned, it's not just about the tech, it's also about the people and the processes. And for example, that first key principle of DevOps, namely collaboration. And at the intersection of these three, we would say that is where MLOps comes into play. You need all of these three components in order to be successful for your machine learning projects. So how can you reduce this tension between DevOps teams and MLOps teams? Well, by creating a bridge between the two. For example, by creating end-to-end machine learning product teams that require at least someone with the skills like a data scientist and someone with the skills like a machine learning engineer, such that you bring both worlds together into the same project, into the same product team, and as a team they operate on the same goal. They do have different skill sets and they might have different parts of the project that they collaborate on, but as a team they ensure that you're not just developing cool stuff, but you're also operating cool stuff. And if you then have this machine learning product team that operates across the board from development to operations, if you have multiple of those, let's say you have one product team focusing on one use case, a second one, a third one, etc., it might also make sense to then create a machine learning platform team that then can support all of these product teams by creating a platform for that. And if you now have those teams and you want to improve on how your people collaborate, on how you put processes in place, on how you iterate on that tooling, it's important to also measure the success of your internal operations. And for that, we can also get great inspiration from the learnings that we got from DevOps. For example, this machine learning team that focuses on one use case can directly leverage the DORA metrics. For example, you might want to record the development frequency, the lead time for change, the change failure rate, and the time to restoration. While on the other hand, if you have an MLOps team that focuses on building a platform that supports all of these teams that work on different use cases, you can look at platform metrics that have been around for a while. For example, platform adoption, the user happiness, and the capability coverage, or the cost per user. So, to conclude, we want to build MLOps on top of a strong DevOps foundation. So, we first want to make sure that we work according to these 5 principles. And from those principles, we can then put the right continuous delivery cycle in place that ensures, for example, the right feedback loops. And on top of that foundation, we can then build DevOps, the MLOps best practices. So bring together the process, the people, and the technology, and operate on all of them. And from there, as an example, you can create end-to-end product teams that have the right DevOps processes in place. And as soon as you have those processes and those teams in place, then let's have a look at this MLOps tooling. Because in our opinion, it's the three things together, the people, the process, and the technology, that enable you to actually get value from the promise of MLOps.
So to conclude, to figure out whether you feel ready for MLOps, we want you to understand why you need MLOps, what is MLOps, and especially when is the timing right for you to do MLOps. So without further ado, we would like to thank everyone.